Welcome to Fire Rescue One's Extra Alarm, your audible source of original content from Fire Rescue One. This is Mark Bayshore, and I'll be the voice of this content for you. Listen to Fire Rescue One content when you're out and about, driving to or from work, when you're looking for some alone time at the station, or during your career development time. And yes, we should all set aside some time each week for learning opportunities. Make sure to listen to the end because I'll be sharing my insights on the topic as well. Let's get started. Electric vehicle fires. Where the waiting game wins, firefighters love testing new tactics and tools, but some methods simply don't address the key issue with EV fires. That's the premise for this article by Troy, Michigan Fire Department Captain Patrick Durham. I want to note that Captain Durham is also a mechanical engineer. Let's get going with his thoughts. With the arrival of electric vehicles comes many different products to solve the problem of extinguishing a fire in an EV's high voltage battery. While there may be a few benefits to some of these products overall, most fail to address the problem associated with the thermal runaway event in a large lithium-ion battery. Here's what you need to know about thermal runaway and the tools and tactics that will actually get the job done, or at least help. Understanding thermal runaway. A high-voltage battery is made up of many cells packed tightly together inside a watertight, fire-resistant box. When a single cell fails, it is essentially a small explosive that produces a tremendous amount of gas and heat, 1200 degrees Fahrenheit, in tenths of a second. The failure is exothermic chemical reaction that does not require oxygen from the atmosphere to sustain itself. The heat released from each individual cell is transferred to the neighboring cells, which causes them to fail as well. Once a battery cell fails, it is impossible to extinguish the failed cell as the chemical reaction inside the cell happens far too quickly. The only way to stop a thermal runaway is by directly cooling the cells involved to ensure that the failed cell does not cause the cells around it to also fail. With that in mind, what tools should firefighters use to stop thermal runaway and extinguish these fires? Firefighting foam. Firefighting foams work by creating a blanket to smother a fire. Many types of foam have properties that cool the surrounding area by assisting the water in absorbing heat. Unfortunately, getting the foam to the failed cells is difficult, if not impossible, because the thermal runaway event is happening inside a watertight, fire-resistant box. Additionally, even if it was possible to get the foam inside the box and flood the area with foam, the foam's main purpose is typically to starve a fire's oxygen supply, but a lithium-ion battery cell does not need external oxygen to burn. Consequently, foam is ineffective at stopping thermal runaway. Class D extinguisher. Class D extinguishers contain a powder that is designed to extinguish combustible metals fires. While they are called lithium-ion battery cells, the cells do not contain solid lithium metal, making the extinguisher ineffective. There is also no easy way to get the powder from the extinguisher directly to the cells on fire due to the construction of the box and the speed at which the battery cells fail. Pancake nozzle. These nozzles are designed specifically to slide under a vehicle and spray cool water at the bottom of the battery box. The water is meant to cool the battery box, ideally stopping the thermal runaway. Unfortunately, extinguishing a fire in the high-voltage battery requires a large, sustained volume of water. The water needs to flow inside the box, directly cooling the battery cells. These nozzles will likely be ineffective due to the design of the battery structure and the numerous layers between underside of the vehicle and the battery cells. Fire blanket. A fire blanket is traditionally used to smother a fire to starve it of oxygen. And as noted, a lithium-ion does not need oxygen from the atmosphere to burn. So, trying to smother the fire will be ineffective. However, these blankets could be used to contain the fire for exposure protection. A word of caution, though, the battery cells give off harmful and flammable gases, hydrogen and hydrogen fluoride, that could become trapped under the blanket. Removing the blanket could cause an energetic fire event when the gases are released. Exposure to hydrogen fluoride could cause permanent damage to firefighters' lungs and eyes. Always wear proper PPE when around any fire. piercing nozzle. Piercing nozzles are designed to puncture the battery box in an effort to deliver large quantities of water inside the box to cool the battery cells. This solution is dangerous due to the electrocution hazard. There is also a possibility of causing more battery cells to fail by crushing cells or shorting out electrical components inside the box. NFPA and EV manufacturers warn against any attempts at gaining access to the inside of the battery box. Never penetrate high voltage components with a tool. While some of these piercing nozzles are designed to be remotely activated, firefighters will eventually have to remove the nozzle from the vehicle. Placement is also a concern, as many battery box structures have cross-car frame rails that are not able to be penetrated. Sealed compartments within the box could also cause a problem for firefighters if the nozzle pierces the wrong compartment and floods an unaffected area. Additionally, the inside of some boxes is filled with polyurethane foam, making it impossible for water to flow through the box. What works? Let it burn. The truth of the matter is, there is no simple solution or tool to stop a thermal runaway in an EV high-voltage battery. Directly cooling the battery cells is the best method. However, the manufacturers do not give first responders direct access to the inside of the battery box. Trying to cool the battery cells from the outside will only extend a crew's time on scene. If the battery box is intact and there are no exposures, the best solution is to simply wait for the battery to burn itself out, then extinguish the remaining Class A fire. While this strategy is not ideal, and not one favored by aggressive, proactive, and eager firefighters, it's really the best approach. It should only take an hour for the battery to burn itself out. The alternative will be continually dump water on the vehicle for 6 to 8 hours. Here's my thoughts. I've done a lot of research on these lithium battery fires, and what I found is that a lot more research still needs to be done. I know that NIST and UL continue to work through a series of tests with best extinguishing solutions for lithium-ion batteries, but again, I know a lot more research still needs to be done. I have a lot of people contact me about the piercing nozzles and how work has been done overseas that shows that the piercing nozzles work and that they can extinguish the fires. And I've asked our NIST folks about that. I've asked the UL folks whether they have gotten us to a point where we can qualitatively say that that kind of research has been done and certified here in the United States. And the fact is that it has not been, and that the testing has been done. However, nothing has been certified in the United States as, quote unquote, the way to put these things out. So unfortunately, until some more research is done and until we identify the right ways to keep firefighters out of a high voltage situation, maybe the best way is just to let it burn. We'll have to keep watching this. This changes quite often with new research that comes out. So keep watching Fire Rescue One for more information. Thanks again for listening, and remember, you can find this article and many more on firerescue1.com. This is Mark Bayshore asking you to keep safe, stay smart, and take care.